Hello and welcome. Today, I'm going to introduce to you the first project that we're going to document on the channel. Behind me is a Warner Swasey paint drafter from the 1960s.
Warner Swasey was widely known for the production of industrial lathes. They also had their hand in the textile industry, as you can see with this unit. Mechanically, it runs great, so I would really have to work on it. Electrically, it is a bit outdated and offers little control or feedback over the process for the operator. There are also some added benefits to this upgrade, like indicator lights and alarms. We are going to change this and make a smarter, more user-friendly machine without altering its original function.
As you can see, this machine has been retrofitted with wiring that is more recent than the 60s. It uses relay logic to operate, which is what we were going to replace with the PLC.
Back in the day, industrial equipment used to be controlled with copious amounts of relays for their logic. However, today, programmable logic controllers, PLCs, govern the functions of machinery with an increased amount of efficiency and have drastically improved troubleshooting techniques. This is what we will try to employ throughout our project.
Coming into our control panel here, we have 240 volts of AC power. This feeds this main switch here. This is going to stay because it is compatible with the door switch that's on the unit, and it'll keep it original. There's a lot of different voltages and things going on inside of this panel due to all the retrofits that have happened over the years. We have 240 volts of AC, we have 24 volts of AC, we have 12 volts of DC, and ultimately by the end of this project, we're going to be standardized with 240 coming in, we're going to use some 120, and then we're also just mainly going to use 24 volts for all of our control signals. We will also be removing quite a few of these old components here. For instance, all of these relays are going to be done away with, as well as this terminal strip that's up here. And believe it or not, we're also going to remove this old transformer from the 1960s. The main feature that's going to be inside of our control panel is going to be a PLC, which will be installed. Since we're working with fiber, and fiber is not the cleanest material to work with, a lot of these components are going to have to be rated to handle this environment. The overall goal for this control panel is to make it look nice and neat and be very easy to troubleshoot. And I think with proper design, we're going to be able to do that very well. Right here is where the third start-stop station used to be installed on this machine. However, we're going to utilize this location for our HMI, our human machine interface, to control the drive speed as well as a lot of the components on this machine. You also may have noticed our oiling system on this. This is not going to be automated because it's all mechanically driven, and it is working phenomenally right now. This is the old variable frequency drive that used to be installed on this machine. However, the customer only has single phase available, and this machine is 3-phase, so we installed this bigger AC Tech SM Vector VFD in an attempt to control the speed. However, this is a little bit clunky when trying to change the different speeds that we want, so we are going to install a PLC instead, since it sets up very well with this VFD.
We'd like to replace some of the old components in this machine, like this yardage counter, as well as these stop-start stations and their wiring. Without further ado, let's see this machine run.
as I said before, this machine is in good working order, but there is another level of control that we can take this to. For instance, having a yardage counter would make it really easy to fill orders to a specified length. In addition to that, the speed that the VFD turns the drive motor on this could be further controlled with the use of an HMI or a human machine interface. Using these things will ultimately make the machine a lot easier to use and more valuable down the road for the end user. Over the course of the next couple months, we're going to be doing a lot of the work to the machine in order to complete this project. This is going to include completely redoing the control panel, as well as integrating a PLC into the system. This PLC is going to be paired with a HMI. All in all, I think this project should be pretty doable. Although I don't have a whole lot of experience with programming and HMI development, there isn't a whole lot on this machine to configure with the PLC. Most of the inputs and outputs on this machine are digital, so they shouldn't be too hard to configure. For instance, the safety loop has a lot of on or off switches. Other than our digital inputs and outputs, we're also going to need quite a few sensors on this machine in order to detect any faults. Fiber has a lot of static, and this could end up breaking through the combing process. Other than that, I think the only analog inputs or outputs that we're going to need for this machine come from the VFD. I don't think anything else will have to be variably controlled throughout this process. Over the course of the next few videos, we're going to be speccing out our components, we're going to be unboxing our components, we will also be programming the components, and then we will see how they wire into the system.